Hi, everybody. Welcome back. So this is going to be our week 2 lesson. We're going to be starting something new this week. This comes from section 3.1 in the textbook. It might be a good idea to write some of this down on a piece of paper so you can look at it later, or if you want to practice as I go. I'll also upload these notes as a PDF to Google Classroom. So I figured to make the homework a little bit easier to complete this week, I decided to make your homework interactive slides. So this is my lesson. I'm going to guide you through the notes in here. Here's what your homework is going to look like. I'm going to click over. Your homework is going to look kind of like the notes. You'll have different questions than what I'm going to guide you through, but where it says you try, you can actually click in here and type answers. So as I go through my notes, I'm going to show you how to actually do these slides. They will be different questions than what you will see in this video. Your homework questions will be different, but I'll at least show you how you can type in your work, and hopefully it'll be a little bit more user-friendly this week. You guys can expect that I'll be trying different things until I find something that seems to work the best for us. So 3.1, inequalities in their graphs. We actually talked about inequalities at the very beginning of the year when we were comparing numbers. So some of this will be review for you guys. So let's open it up with a question. Let's say Alex plays in the under 15 soccer, 15 obviously being the age. How old is Alex? Can we describe his age as one specific number? Well, if you think about it, there's a lot of answers to this question. He could be 14. He could be 13 and a half. He could be 10. There are a range of answers. Okay, so there's not one specific answer. There's a range of answers. So it's not an equation, right? If we were solving an equation like x plus 5 equals 10, you could figure out the exact value of x, and it would be one specific value. But in this problem, his age isn't one specific value because we don't have enough information, right? We just know that he's under 15. Well, that could mean a lot of things. So long as I give you an age that's younger than 15, it works as a solution. That's an inequality. That's what an inequality is. An inequality is a mathematical statement that uses one of these 4 symbols instead of an equal sign. Okay, so reading left to right, I'm going to go ahead and define what each of these symbols mean. This symbol, if I was reading it left to right, means greater than. This symbol, if I read it left to right, means less than. You probably knew all of this already. This symbol means greater. Oops, I got to take off my underline. So as I go through this, I'll show you guys how to format stuff. So when I typed this symbol, to get this bar underneath, I clicked the underline feature. To turn that off, so that way my font here still isn't underlined, I'm going to click it again and it turns it off. So that's what we're going to be doing. Every time I need to type a symbol that has this bar underneath, I just underline it. You just got to make sure that as you keep typing to turn it back off again. So reading left to right, this means, it wants to underline the space. So let me highlight this and not underline it. This means greater than or equal to. I'm gonna have to turn my underline off for here as well. So all I did was I clicked it. It'll highlight it to show you it's on. Reading this symbol left to right means less than or equal to. We did a slide similar to this back when we were covering stuff in chapter 1. Now, it's important to note that at the very top here, I said that we were gonna read these symbols left to right. And the reason why that's important is because you can read them right to left. And if you read them right to left, it changes what they mean. So let me show you what I mean here. If you were to look at an inequality, this inequality right here, for example, this reads 5 is greater than 2. You can kind of think of it as like a little Pac-Man mouth or an alligator mouth. It always wants to eat the bigger number. Okay, so this statement here, if I read it left to right, reads 5 is greater than 2. And that is a true statement. If I flip the numbers around, I gotta flip the direction of this symbol in order to maintain that it's still true. So just make sure that your sign faces the correct direction. If you flip the numbers around in an inequality, you gotta flip the symbol around as well. So just be really, really careful with how you're writing inequalities and how you're reading it. Let's start with some basic translations. So all I'm gonna do is go from words to just numbers and math symbols. It says all real numbers less than or equal to -7. So when you're not sure how to approach a problem, you can box, highlight, or circle important information. I'm going to highlight stuff because I think that's going to be the easiest way to approach this problem electronically. I see an X, so I know I'm going to have an X in my answer. Less than or equal to is going to be my inequality symbol. Maybe I should color code stuff in here as well. So here's my X. Less than or equal to, if I read it left to right, I want the X to be less than the -7. So I'm going to leave a space here. I know I'm going to need a number. Let's make it purple. So I know I'm going to need, and you don't have to color code your answers like this. I'm just doing this for right now to kind of show you how you would break a problem down. But you certainly don't have to color code things like this. In fact, I won't do color coding for the next one just to kind of simplify it. But I just wanted to show you that you've got, at least 3 different pieces to a word problem like this. You're going to have a variable, at least one variable, at least one number, and then some sort of phrase that translates into one of these 4 symbols. So if I want the X to be less than the number, that means that the number is the bigger value. That means that I want the Pac-Man mouth to be facing that way. And all I'm doing is I'm typing those symbols on my keyboard. They're right at the bottom next to the M. There's both of those symbols. You just have to hold the Shift key down in order to press them, or excuse me, in order to type them. So now I need to double check, do I want a bar underneath my symbol? Well, that's what these bars mean, greater than or equal to. I want it to be or equal to, so I definitely want the bar to be underneath. So I'm going to highlight this symbol, and then I'm going to go up here and press the underline button. Poof, the bar underneath shows up. Let's try another one. So you'll have one like this as well, where you're going to do a translation. A number k minus 6. So now we've got an entire expression, k minus 6. So it's giving me an operation. Well, what operation is minus? Well, it's actually telling you minus is just minus, it's subtraction. So I'm going to do k minus 6. So I've got a math operation. Is greater than 13. So right now I'm going to leave a space, and then I'm going to put 13 right here. So my inequality symbol is got to go here, right in front of the 13, just like in the symbol, or excuse me, just like in the word problem. See how greater than is in front of the number? Greater than is going to be in front of the number here. So the question is, which piece is bigger? Is the subtraction part of my problem the bigger value, or is the 13 bigger? Well, it's telling me that k minus 6 is greater. K minus 6 is the bigger value. So if I was looking at the inequality symbol as a Pac-Man mouth, it wants to eat the portion that says k minus 6 because this is the part that's greater than. This is the part that's bigger. Now I'm just going to double check if I need the bar underneath. Well, it doesn't say or equal to, so I don't want the bar. So I leave it like that. So this is my final answer, and for number 1, this was my final answer. So you'll have a couple like that to try on your own. Now let's talk about how to find a solution to an inequality. You'll have a couple problems like this as well, where I give you a number and I ask you, is this a solution to this inequality? Well, let's read what a solution is. A solution to an inequality is a value that results in a true statement when substituted for the variable. That means that if I do a check, if I check this number in this inequality, and it results in a true statement, then that means the number is a solution. So I'm wondering how many people remember how to do checks. I did show you guys when we were solving equations. To do a check, you're going to take the inequality, but instead of an x, you're going to substitute this number. And the best way to substitute it is to use parentheses. And the reason why you want to use parentheses is because 2x means 2 times x. If I don't use parentheses, here's what it's going to look like. So 2, replace the x with the 3. What does that look like to you? Does that look like multiplication? No, it looks like subtraction. So I'm going to surround my x value with parentheses. And then everything else in that inequality, the +1 greater than -3, that all stays the same. Okay? And when you're doing a check, you're not trying to solve anything. I'm not moving terms from the left to the right and vice versa. I'm just looking on the side that contains operations and using order of operations to simplify it down to one number. So throughout my work here, I'm just going to be working on the left-hand side. I have multiplication and addition. Order of operations says do multiplication first. So I'm going to do 2 times -3. I encourage you to use a calculator. If you don't have one, do what I showed you in the last video. You can go online, just go to Google. If you've got a cell phone, that has a calculator app, use the app. Or you can also use that scientific calculator I posted a link to on Google Classroom. It was called Desmos. A lot of options there. So 2 times -3 gives me -6, but I still have all of this. +1 is greater than -3. Last but not least, I'm going to add these. -6 plus 1. If you do this in your calculator, you should get -5 is greater than -3. Okay, so I've got it down to one number on the left, one number on the right. Now I want to read this statement and see if it's true. This is saying, if I read it left to right, -5 is greater than -3. Think about this very, very carefully. Negatives work the opposite from positives. If both of these were positives and it said 5 is greater than 3, that would absolutely be true. But negatives work backwards. -5 is not bigger than -3. It's not greater than -3. It's smaller than -3. And the way I like to think about negatives is temperature. What's a lower temperature outside? Okay, which one's actually a lower temperature? -3 below 0 or -5 below 0? This is actually the smaller number. So it's not the bigger number, which is what this says. It's the smaller number. This inequality is not true. So -3, I'm going to type this out. -3 is not a solution because this is false. Okay? Let's try another one like this. I gave you the same inequality in the next problem, just a different number to check. We're going to do it the same way. Instead of 2 times x plus 1, it's going to be 2 times -1 plus 1. So again, I'm using parentheses because this here means multiplication. I don't want it to look like subtraction. And I also have to copy down the rest of the inequality. There's a symbol and a number. Same thing as last time. I'm going to multiply first. 2 times -1 gives me -2. I bring down the +1 is greater than -3. Last operation, I combine these like terms here. -2 plus 1 gives me -1. And I bring down my inequality and number. Now that I've got everything down to one number, I need to read this statement to see if it's true. If it is, this is a solution. If it's false, this is not a solution. It says -1 is greater the -3. So same thing as last time. Both of these are negative, so you kind of have to think backwards. If they were both positive, this would be false. But because they're both negatives, it's actually true. Another way to think about it, let me just draw a little number line real quick. Hopefully I can do this easily. If I draw a number line, right? You guys can see how I create number lines here. And I were to number this number line, I'm going to start by doing some negatives. -2, -1, 0, 1, 2, and so on, right? If I were to number this, let me make it shorter here. I screwed up my number line. It's not straight anymore. That's going to bother me. I want it straight. Come on. There we go. Now it's perfect. So I've got my numbers on this number line, right? I just don't have my little tick marks on it. I won't be that finicky right now. But look at how the negatives and the positives are ordered, right? Negatives flow backwards. The numbers that are going to be closest to 0 are going to be bigger, right? So -1 is right here. -3 is all the way over here. I just didn't label it. -1 is actually a bigger number. And again, you can think about it like temperature. -1 is a warmer, a higher temperature than -3. So this is a true statement. -1 is bigger than -3. So I'm going to go back and say -1, which is the number I tested, is a solution. Okay, it's important to understand that when I write this statement here, I'm not using the numbers in my final answer. I'm using this one. Let me highlight here. I'm using the number that I checked, right? Same thing back here. I didn't use the -3 in this answer. I used this -3. I was saying the -3 that I plugged in is a solution, or excuse me, is not a solution for this one. Okay, so you're going to have a couple of problems like that where you plug in a number, do order of operations, and determine, is it a solution? Is it not a solution? Now for the real meat and potatoes of this lesson, how to graph inequalities on a number line. So on every slide moving forward, I've given you kind of like a little handy dandy chart. So when we graph inequalities, we're going to graph it on a number line. I just did a very crude example of a number line on this previous slide. On all the slides moving forward, I'm going to give you a blank number line like this, and we're going to have to add numbers to it. So we want to make sure that we're numbering it in a logical way, that as you read the number line left to right, the numbers are increasing. And within an inequality, when you're graphing it, you're going to use a couple of different things. You're going to have to put a circle above the number that you're graphing. It's either going to be an open circle if the symbol within the inequality does not have a bar, or you're going to color that circle in if there is a bar. And then you're going to have to shade your number line in a specific direction. If your inequality symbol, if you looked at it like a mouth, is eating the variable, shade to the right. If the inequality symbol is eating the number, shade to the left. None of this might make sense right now, but I'm hoping that as I do this and I refer to this table up here, you'll see what I'm doing here. So let's do a few together. X is greater than 1. Always start by reading the inequalities starting with the variable. X is greater than 1. Okay, so first and foremost, step 1. I'm listing all the steps down here. Step 1, number your graph. Well, I definitely have to have 1 on my graph. I usually like to put the number that is in the inequality on the center tick mark, and then I surround it with a number to the left and a number to the right. It doesn't have to be a distance of 1 for each of these numbers. And they don't even have to be equidistant, so long as the number that's to the left of the 1 is smaller. So let's think about a number that's smaller than 1. Well, the easiest one I can think of is 0. So I'm going to put the 0 here. I'm going to put the 1 in the middle. And I'm going to put a bigger number to the right. I'm just going to use 2. You didn't have to use 0. You could have used negative 1,000 if you wanted to. You didn't have to use 2. You could have used 100 if you wanted to. So long as the number that's to the left is smaller, and so long as the number to the right is bigger. Okay, step 2 is done. Step 1 is done. I've numbered the graph. Step 2, I need to drag and drop the appropriate circle. It's either going to be an open circle or a closed colored in circle. This is where you got to go back and look at this chart here. This table up here in the corner tells me that if my inequality symbol does not have a bar, I use an open circle. If my inequality symbol does have a bar, I used a closed circle. That means or equal to. And you can kind of think of it like this. The bar underneath means you want the number to count. Think about when you guys take multiple choice tests. Like if you were taking, an SAT or the PSAT back when you guys bubbled in stuff. If you wanted your answer to count, what did you do on the Scantron? Well, you colored the circle in. The bar underneath means I want the number to count. I color the circle in. If it doesn't have a bar underneath, it means I don't want the number to count, so I leave it open. This symbol here does not have a bar. So above the 1 in my number line, you always put it above the number. I'm going to take the open circle and put it above the 1. Sometimes students will put it on the actual number line itself. You can totally do this. I prefer to do it above so you can really see it. If you want to do it on the number line itself, go for it, just so long as it's very clear. All right, step 3, drag and drop the correct shading. I'm either going to use this one if I want all the values to the right, like that, and I shade to the right, or I'm going to use this one if I want to shade all the way to the left and include the numbers to the left. But I need to figure out which one to use. So I go here, I go to the bottom row. If the symbol eats the variable, I shade right. If the symbol eats the number, shade left. Well, let's take a look and see which one it's eating. So if I look at this like a mouth, it's eating the variable. If it eats the variable, I want to shade everything to the right. Here's why. This reads x is greater than 1. That means that I want all the values greater than 1. Well, all the values greater than 1 on a number line are going to be to the right of 1. See how 2 is captured in the part that I'm shading? 2 is greater than 1. If I kept going with my number line, 3 would be over here. 3 is greater than 1. All the numbers to the right, which is where I'm shading, are greater than 1. And that's done. That's how you that's how you graph an inequality on a number line. You number the number line, the number that you're graphing goes in the middle. You choose an open or closed circle above that number, and you shade to the right or the left. Let's do another. A is greater than negative 2. Okay, well now I got to be careful. Now I've got negative numbers. So if I want my negative 2 to be in the middle, then I want a number that's smaller to the left. Think backwards for negatives. The number that's smaller than negative 2 is negative 3. Negative 2 goes next, and the number that's bigger than negative 2 is negative 1. So step 1 is done. I've numbered my graph. Next, I have to determine what type of circle to use, open or closed. That means I look at the symbol. It does not have a bar underneath. That means I use an open circle above my number. Now I need to determine which direction to shade. Do I shade to the right or the left? It depends on which one the inequality is eating. Well, the inequality is eating the variable. That means that if it's eating the variable, I shade to the right. So I want to take the arrow that's pointing to the right and connect it to my circle here. Done. You know what? I'm going to change this problem. I'm going to do an impromptu change. I'm going to put a bar underneath this symbol. Make it different because we haven't come across one like that yet. All right, so another one that we'll do together. If I read this left to right, this says -6 is greater than or equal to G. So I put a bar underneath this one. Step 1, number your graph. Well, if I want -6 to be in the middle, I need to pick a smaller number to the left. And again, negatives work backwards. So -7 is actually smaller than -6. -6 I'll put in the middle, and -5 is actually bigger. Step 2, drag and drop the correct circle. Well, if I look at this symbol here, that's going to tell me what type of circle to use. There's a bar underneath. This time I want a closed circle. So I'm going to drag and drop this closed circle because I want the number to count. This says or equal to -6. That means I want the -6 to count. So just like on a Scantron, when you want your answer to count, you color the circle in. Now I need to figure out which direction to shade. Well, if I look at which one Pac-Man is eating, it's eating the number this time. If it eats the number, I shade to the left. So I want the arrow that's pointing to the left, and I'm going to connect it. There we go. Done. All right, last thing that we'll cover before we wrap up our lesson today. How to go backwards, how to go from a graph to an inequality. The easiest way to do this here is to look at the number beneath the circle and start by typing that, okay? So I know that my inequality is going to have a 1, and I know that I'm going to have a variable. I always like to put the variable to the left, okay? So I moved my cursor over to the left of the number. And it does not matter which variable you use. You could use X, you could use Y, you could use B. I'm just going to use X. And then in between your variable and your number, you're going to choose the appropriate inequality symbol. To figure out what type of symbol to use, you can kind of go back to these charts even if it helps you. You're going to look at the direction of the shading. If it's going to the left, I want the variable to be less than. If the shading had been going to the right, I want it to be greater than. You can also think of it like an arrow. If I ensure that my variable's on the left, the symbol I choose kind of needs to point in the same direction as the shading. Okay, see how they're both kind of pointing to the left here? That trick only works though if you're putting the variable on the left. Last but not least, I need to determine, do I want to hit the underline feature to put a bar underneath this or not? You look at the type of circle, okay? If the circle's closed in, which it is for this one, I want it underlined. So there's my final answer. I'll do several more with you like this. All right, so first thing I'm going to do, I'm going to type the number that I see. The circle is above. It's above the 5. And then I'm going to go back to the left, and I'm going to add a variable. In between my variable and number, I want to determine, do I want it to be less than or greater than? I look at the way that it's shaded. It's shaded to the right, so I want X to be greater than. And again, if you're putting your variable on the left, you can kind of look at them as if they're arrows pointing in the same way. My shading's going to the right, so I want my symbol to point to the right. Last but not least, I determine if I want to underline it or leave it as is. This circle's open, so I leave it as is. I don't want the bar here because the circle's not colored in. This is my final answer. Here's another one. I'm going to start by typing the number the circle is above, and I'm going to go to the left and add a variable. Now I need to figure out which direction do I want my symbol to point. Well, if my shading is pointing to the right, I want my symbol to point to the right. Now I need to figure out, do I underline this or not? Well, my circle is closed. That means I want this to be or equal to. So all I did was I highlighted the symbol and I clicked underline. Done. There's my final answer. Last one, I want to type the number. The circle is above. I'm going to go to the left and put a variable. And now I'm going to match my inequality symbol to point in the same direction my shading is pointing to, and that's to the left. Last but not least, do I underline this? Well, the circle's open, so I don't want the bar underneath. Here's my final answer. And that wraps up our lesson today. So your homework is to complete all of the You Try slides in your interactive slideshow that I'm going to be uploading. They are different problems than what I just guided through here, but do rewatch this video if you're confused on a particular slide, because it kind of guides you through how to approach the problem. It's not going to be the exact same one, but it should be enough to guide you through how to do this. Of course, if you run into any questions, any issues, you can comment on Google Classroom, you can message me there, you can email me. And if all is said and done and you're still confused, you can just shoot me an email that you'd like to do a one-on-one Google Meet hangout, and I can try to walk you through in real time. Okay, so we'll end it there. Take care.